Welcome to the Explainer. If you've ever built a Retrieval-Augmented Generation system, what we all lovingly call RAG, you know that absolute high when your prototype finally works on your laptop, right? You type a question, it searches your local documents, and boom, it generates this brilliant, perfectly cited answer. It literally feels like magic. But taking that magic from a local, contained prototype to massive enterprise-scale production? Oh, that is an entirely different beast. Today, we're tearing down the IOPS Vista blueprint for production RAG architectures. We're going to expose the hidden, frankly terrifying pitfalls of scaling these systems, and more importantly, we're going to build out the foundational 6-layer blueprint with a massive focus on observability to actually solve them.
Okay, let's dive into this, because this right here is the true villain of our explainer today. You see, in traditional software, when things break, they break loudly. Servers crash, error rates spike, pagers go off in the middle of the night. But RAG systems, they fail silently. Standard HTTP metrics might show a perfectly healthy system, like your dashboards are glowing a beautiful, reassuring green, while your AI is actively hallucinating, or spitting out stale information, or completely missing the context it needs to actually help the user. The system is fundamentally broken, but your standard metrics are sitting there telling you everything is totally fine. So, here is the structured journey we are taking together today to fix this. 1. The silent RAG failure. 2. The 6 architecture layers. 3. Inside the retrieval trap. 4. The observability stack. 5. The deployment pipeline. And finally, 6. Production readiness indicators.
Let's jump right into Section 1, the silent RAG failure.
Imagine this scenario. Without trace context, your standard metrics are proudly showing a 200 OK status code. Your API gateway is practically bragging that the request was successful. But a latency spike or a garbage answer isn't just a blip on a graph, right? It is a real, frustrated user staring at their screen. Now, when we introduce OpenTelemetry trace context, the whole illusion shatters. We can suddenly see that beneath that proud 200 OK, the actual retrieval quality is silently degrading. Standard metrics completely miss these underlying AI failures because they're only measuring the plumbing. They have absolutely no idea if the water flowing through that plumbing is clean or toxic.
Moving on to Section 2, the 6 architecture layers. This is our foundation.
And this brilliantly illustrates the core of our solution. A production RAG stack isn't just some messy Python script calling an OpenAI API. It is 6 distinct, independent vertical layers. You've got the client layer handling your API gateway and auth, orchestration, which manages query routing and guardrails, then the retrieval layer holding your embeddings and ANN index, the generation layer routing to your actual LLMs, the storage layer, utilizing things like pgvector and Redis. And finally, and pay attention here, because this wraps around the whole shebang, the observability layer with OpenTelemetry and Prometheus. Every single one of these vertical layers acts as a critical building block. They have to scale independently, and crucially, each layer has a strict observability contract. We have to track latency, error rates, and quality signals at every single layer, no exceptions.
Because think about what happens when a user submits a query. It doesn't just teleport to the LLM. It runs a highly deterministic 6-phase gauntlet. First, the input is received. Second, we vectorize that query into an embedding. Third, we retrieve the relevant documents. Fourth, we score and re-rank those docs to find the absolute best match. Fifth, we assemble the context prompt, and only then, way down in step 6, do we actually generate the answer. Now guess where things usually break? Yep, right at the microscopic interfaces between these steps. Let's talk about step 2 for a second. The vectorized step, because this is such a classic trap. 40 to 120 milliseconds, that's the typical latency range for the embedding step. Now I want to offer a bit of tech horror warning here, based on this blueprint. Never, and I mean literally never, co-locate your embedding model with your inference cluster. If you run them on the same hardware, the heavy compute of the LLM will absolutely starve your embedding model. You'll trigger these cascading latency spikes under load that will bring your whole system crashing down. Always run a dedicated embedding microservice with connection pooling. Trust me on this one.
All right, on to Section 3, inside the retrieval trap.
Here is the absolute most common silent killer in production defined: embedding drift. This happens when you update an embedding model. Maybe you thought, hey, I'm deploying an awesome upgrade, but the new embeddings don't perfectly align with the old ones sitting in your index. Suddenly, your retrieval quality begins to degrade silently over like a 48-hour period. Meanwhile, your P99 latency, your absolute slowest requests, remains totally stable. Your standard metrics don't fire a single alert. If you aren't monitoring this specifically, your users are going to notice your AI is giving garbage answers long before your engineering team ever sees a warning light.
It's a massive operational risk.
To escape this retrieval trap, your infrastructure needs to be fast, like blazing fast, sub 10 milliseconds. That is the 95th percentile target you want for approximate nearest neighbor, or ANN, search latency, assuming you're using an HNSW index to structure your vectors. And what's wild is that you can actually maintain this sub 10 ms speed for massive corpora, up to 50 million vectors. But word of warning, once you cross that 50 million threshold, that's when you have to start sharding the index horizontally, querying those shards in parallel, and merging the ranked results before your re-ranking step.
Which brings us perfectly to Section 4, the observability stack, the real hero of our story.
Production RAGs demands 4 very specific categories of telemetry that go way beyond your standard HTTP logging. You absolutely need signals for query quality, retrieval health, generation safety, and infrastructure. You aren't just looking at CPU usage anymore, folks. You need to be tracking cache hit rates, guard block rates, and retrieval mean reciprocal rank. Wait, actually, let me define that. Mean reciprocal rank tells you if the correct answer is actually showing up at the very top of your search results. Without these 4 specific signals, you're flying completely blind.
So the crucial point is this. Every single retrieval call has to be instrumented from day one. How? By injecting custom OpenTelemetry trace context starting at the API gateway and passing it all the way down through to your vector database query. You need to log specific attributes, things like rag.query tokens, rag.retrieve chunks, rag.re-rank score top 1, and rag.context tokens. These exact specific trace attributes are what power the dashboard that finally tells you if your AI is actually working, rather than just telling you the server happens to be turned on.
Moving to Section 5, the deployment pipeline.
Look, a standard CI/CD pipeline just isn't going to cut it for RAG. You need these 4 specific deployment gates. First, document ingestion, where you parse, chunk, and embed, strictly rejecting any chunks that fall below a quality threshold. Second, the index warmup and quality gate. Here you run benchmark queries to ensure both latency and accuracy are hitting the mark. Third, and please don't skip this, a canary rollout. You route just 5% of your production traffic to the new version for 30 minutes. You watch those custom telemetry signals we just talked about like a hawk, and if a service level objective breaches, boom, automated rollback, no manual intervention. Only after that 30-minute window clears do you move to step 4, full production promotion.
And finally, Section 6, Production Readiness Indicators.
So, when is your system actually ready for the real world? Only when it satisfies these 4 hard operational contracts. Number 1, retrieval quality has to maintain a mean reciprocal rank of 0.80 or higher, meaning your best answer is basically always in the number 1 spot, and you must measure this at least weekly against an evaluation set to catch that dreaded embedding drift. Number 2, your latency budget must be extremely tight. We're talking a P99 end-to-end latency of 3 seconds or less, even under peak load. Number 3, total observability coverage. All 4 of those telemetry signal categories have to be fully instrumented. And number 4, you must retain your previous index snapshot with a documented, tested, sub-5-minute rollback path. I'll say it plainly, if you can't roll back in under 5 minutes, you are simply not ready for production.
Which leaves us with a pretty unsettling thought to close out this explainer. I really want you to look at your own architecture right now and ask yourself, if your retrieval quality degraded today, if your AI started silently handing out worse answers to your users this very second, would your current metrics even fire an alert? If your answer is no, then it is absolutely time to audit your observability strategy and put this blueprint to work. Keep building resilient systems and don't let your RAG fail in the dark.